गुड मॉर्निंग स्टुडंट्स, आवाज येतोय का? राइट युअर नेम अँड सीट नंबर. पोकळे, आवाज येतोय का? अनम्यूट केले तुला मी. पोकळे, सार्थक आवाज येतोय का? आहे का सार्थक जोशी? टाइप इन चॅट बॉक्स. ओके अवधूत, टाइप इन चॅट बॉक्स. I got the message. ठीक है, we will start. Last lecture on Friday we started this new chapter. The name of the chapter is Ionic Equilibria. This is newly introduced chapter in this year for the 12th standard. This chapter was originally present in 2008 syllabus, but in 2012 syllabus it was deleted. But for the demand of NCERT, for the JEE, NEET and CET examination, for the competitive examination, again this chapter is included in this year. It is a very small chapter. It is having only 15 pages, but the weightage is very large weightage. 6 marks weightage is there with option, and without option 4 marks weightage is there. So introduction part is already completed. What is mean by equilibrium? Ionic equilibrium, it is nothing but the equilibrium between ions and unionized molecules. Remember ions, you are familiar with this word ions. Ions are positively charged, it is called as cations. Negatively charged, it is called as anions. And the equilibrium between ions and unionized molecules. Unionized molecules means they do not form ions. So in this chapter only we will discuss the equilibrium between ions and unionized molecules in the solution. This is called as ionic equilibria. Before starting this chapter, you must know what is meant by electrolytes. The substances which produce ions, when dissolved in water, it is called as electrolytes. So this part is explained in the last lecture, what is meant by electrolytes. So electrolytes are the substances which produce ions when dissolved in water. For example, NaCl, when this one experiment is shown here. This is a water is taken in a beaker and NaCl salt is added. So when NaCl is added in water, it forms ions, positively charged Na plus, we can see here, and negatively charged Cl minus. Ions are prepared. Another example is copper sulfate. Also, when it is dissolved in water, it produces iron. So such substances are called as electrolytes, and non-electrolytes means they do not ionize. They exist as molecules in aqueous solution. For example, urea, ethanol, methanol, glucose, sucrose. When they dissolve in water, they do not form ions. They exist as a in molecular form. So electrolytes, again, these are classified depending upon the extent of ionization, strong and weak electrolytes. Strong electrolytes, these are the substances which are completely dissociated or completely ionized. For example, strong acids, strong bases, and salts. These are called as strong electrolytes, which completely gets ionized or completely dissociated in water. Then weak electrolytes, these are the electrolytes which dissociate in a smaller extent in aqueous solution. For example, weak acid, weak base. And these weak electrolytes, its dissociation always shown with this double-headed arrow, because these are the partially dissociated in aqueous solution. This double-headed arrow indicates the equilibrium between ions and non-ionized molecules. Then this part is also completed degree of dissociation. It is mean by alpha. It is denoted with symbol alpha. Remember, the formula is very important. It is the number of moles dissociated divided by total number of moles, and percent degree of dissociation is alpha into 100. Then we also discuss what is mean by acid, what is mean by base, according to the different theories. There are three theories explained by the three different scientists. First one is Arrhenius theory. Just I will take the quick revision. According to this Arrhenius theory means what? Acid is acids are the substances which contains H plus ions and which gives rise H plus ions in aqueous solution. Means acid is the substances which already contains hydrogen. So this example is taken HCl. When dissolved in water, it produces H plus ions and Cl minus ions. So according to the definition of Arrhenius theory, they produces H plus ions. So this is a completely dissociated. Single arrow means HCl is completely dissociated. H plus and Cl minus are separated. But this is an example of weak acid, CH3COH. See the double-headed arrow means this is a partially dissociated CH3CO minus and H plus. According to the definition of Arrhenius theory, these substances having the hydrogen and gives rise H plus ions. But this is a weak acid. Then what is the base, which is having the OH group and produces OH minus ions in aqueous solution. So NaOH, when it is dissolved in water, it completely dissociates, gives Na plus and OH minus. So this, according to this definition, OH minus ions are produced in aqueous solution. So it is a base, strong base, because completely dissociated. And NH4OH, it is its dissociation is shown with double-headed arrow. So this double-headed arrow indicates this is partially dissociated. It produces NH4 plus and OH minus ions. So this is a weak base. Then this Arrhenius theory is completed, but Arrhenius theory didn't give the answers why NH3 is base and Na2CO3 is base, because they do not contain OH group. Still, they are bases. So another scientist, Laurie Bronsted theory, explained what is meant by acid and what is meant by base. So according to this Laurie Bronsted theory, acids are the substances, they donate protons. So acids are proton donors and bases are proton acceptors. So this one example is given in this HCl and this NH4. This HCl and this NH4 plus, these acts as acid because these are proton donors. And this NH3 and Cl minus, these are acts as a basis because these are proton acceptors. So they also forms a conjugate acid and base. This part is very important for the regarding the board examination, because for 2 marks or 1 mark they can ask this question: what is mean by conjugate acid base pair. So for your understanding purpose, I have given this one example here, and see, for understanding, I added this picture here. So adding a proton to the base gives conjugate acid. Means if the proton is added to the base, conjugate acid is formed. See this example. This is acid HCl, and this is acid and this is a base. So this is a acid base pair. And what is base? Removing proton from the acid gives the conjugate base. So this is the conjugate base because from this the proton is removed. And what is a conjugate acid? Conjugate acid is a substance in a base. So if Cl minus is considered as base, in which the proton is added, it is the conjugate acid. See, the base is, first we will discuss what is mean by acid, conjugate acid. So adding a proton to the base gives the conjugate acid. Means if this is a base, so in which the proton is added, we get here HCl. And removing a proton from the acid gives the conjugate base. If this is acid, in which if the proton H plus is removed, we get the base. So conjugate acid base pair, it is nothing but in which there is a difference of one proton only. If we consider this example, this is H2O is a base and H3O plus is an acid. So according to this definition, see here H3O plus is acid because H2O is base, in which the proton is added, it becomes H3O plus acid. Proton is removed, it becomes base. So conjugate acid base pair means acid and base only having the difference of one proton. This is called as conjugate acid base pair. Now we will discuss, this part is already explained, Lewis theory. This is very, very important. What is meant by Lewis acid and Lewis base. Already from 11th standard we are discussing this word. NH3, ammonia. In this chapter amines also we discuss. Ammonia is basic in nature because because of this lone pair. So acids are the substances which accepts electron pair. What is Lewis acid? Lewis acid, these are the substances which accepts electron pair, and the bases are the substances which donates electron pair. So in these examples, this NH3 ammonia having this lone pair of electron, if this lone pair is given, it acts as a base, and this H plus acts as acid because it accepts electron pair. The H plus accepts electron pair, and this NH3 donates electron pair. So according to the definition of this Lewis theory, this ammonia is a base. See, for the board examination, this is asked for the examination. Sorry, for the board exam, this is asked for 1 mark. Why? Amines are basic in nature, so we have to show these arrows. We have to draw the structure of here ammonia lone pair, this H plus when this lone pair is donated. So according to the Lewis theory, electron pair donors are called as bases, and H plus is acid because it accepts electron pair. So at a glance we can remember these three theories. What is meant by Arrhenius theory, acid and base? It is given acid base definition, H plus OH minus. Then Bronsted-Lowry, this is proton donors, proton acceptors. Then Lewis theory, electron pair acceptors and electron pair donors. So we have to remember at a glance because For the 1 mark or 2 marks question, they can be asked, explain acid and bases according to Arrhenius theory, explain acid and base according to the Lewis theory, explain acids and bases according to the Lowry-Bronsted theory, or explain conjugate acid-base pair. So the questions will be, this type of questions will be asked on this topic. Then amphoteric nature of water, this is also explained. Water is amphoteric in nature because it shows the properties of it acts as acid as well as base. These reactions are shown. In this reaction, this water, it is a proton donor, acts as acid, and in this equation, this acts as a base because it is a proton acceptor. Then ionization of acids and bases, according to the extent of ionization, we can consider a strong acid, strong base. See here, depending upon the extent of dissociation in water, strong acid and strong base, or a weak acid or weak base, we can identify. So HCl here we can see it is shown with dissociation, which is shown with single arrow. It dissociates in water H plus and Cl minus completely. So it is a strong acid. NaOH, according to the Arrhenius theory, this is a acid because it produces H plus ions. According to the Arrhenius theory, NaOH is base because it produces OH minus ions. See, single arrow indicates completely dissociated, so it is a strong acid. HCl is a strong acid, and NaOH is a strong base because according to the definition of base, NaOH produces OH minus ions, HCl produces H plus ions, completely dissociated. So the concept should be clear. What is meant by acid? What is meant by base? What is strong acid? What is weak acid? Strong acid means completely dissociated. Weak acid means partially dissociated, not completely dissociated. See these examples I'm giving CH3COH, acetic acid. So according to the definition of Arrhenius theory, it produces H plus ions, but see the double-headed arrow indicates it is partially dissociated, means completely it is not dissociated. Completely we didn't get this ions, CH3CO minus and H plus ions. So it is a weak acid. Then again I'm coming to the example of weak base, NH4OH, it is considered as a weak base. First, it is a base because it produces OH minus ions, but it is a partially dissociated, not completely dissociated. So it is an example of weak base. Some more examples are given here. In strong acids also, this HCl, HNO3, H2SO4, HBr, HI. These are the examples of strong acids because they completely dissociates. And NaOH, KOH, these are the examples of strong base because they completely dissociates in water. Then I'm coming to the examples of weak acid, HCOH. HCOH, you know, this is a formic acid, HF, hydrofluoric acid, H2S. These are the example of weak acids because these produces H plus ions but not completely dissociated. These FeOH thrice, COH thrice. This is ferric hydroxide. Then this is cupric hydroxide. These are the examples of weak bases because these do not completely dissociate in water. So the new part today we will start this already. Whatever the part I discussed, this part is already completed. Just I have taken the quick revision. Now I will discuss this dissociation constant of weak acids and weak base. Now you are very familiar with the strong acid, what is meant by acid, what is meant by base, what is meant by strong acid, what is meant by weak acid, weak base. So these concepts are clear. Now I am coming to the dissociation constant. So to understand the dissociation constant of weak acid and weak base, we are considering only the weak acid and weak base. Now you are very familiar with weak acid means they cannot completely dissociated. They are always, their dissociation is always shown with double-headed arrows. So first we will discuss the dissociation of weak acid. Suppose this weak acid HA is taken, and in water it dissociates as like this. HA in aqueous means it is dissociated in water. So it produces H plus ions and A minus ions in aqueous solution. So the equilibrium constant, now see this word is given, the equilibrium constant K. Ka, this is the equilibrium constant of acid, and Kb, this is the equilibrium constant of base, remember. So this equilibrium constant is given by this formula. Ka is equal to, we have to take the concentration of the products divided by the concentration of reactant according to the law of mass action. In 11th standard, this law of mass action is already, we learned about this law of mass action. So according to the law of mass action, the concentration of the products H plus, see this molar concentration as always shown in square bracket. So the molar concentration of H plus and the molar concentration of A minus, this is the product of molar concentration of the products, means H plus multiplied with A minus divided by the molar concentration of the reactant. This is my law of mass action actually. So according to the law of mass action, the molar concentration of the product divided by the molar concentration of the reactant. So HA, here HA is the reactant, here H plus and A minus, these are the ions dissociated in water. So this is equation number 3.3. So weak acid BOH, it will be dissociated in water. BOH, here it is a weak base. It will be dissociated as B plus aqueous and OH minus. So again the equilibrium constant Kb. Now Kb, it is a equilibrium constant for the base. Ka, this is equilibrium constant for the acid. So similarly, according to the law of mass action, molar concentration B plus, molar concentration of OH minus divided by the molar concentration of BOH. This is equation number 3.4. So the dissociation constant of weak acid or weak base is defined as the equilibrium constant for the dissociation equilibrium of weak acid or weak base respectively. Means the dissociation constant and equilibrium constant are similar. Now I am coming to the Ostwald dilution law. This is a new part. For the board examination, this question is always asked for 2 marks. Means this question is asked like this: explain Ostwald dilution law for weak acid, or explain Ostwald dilution law for weak base. So there are 2 expressions for weak acid is one expression, and weak base there is another expression. So what is this actually Ostwald dilution law? I will explain. Ostwald, this is the name of the scientist who given the relationship between the degree of dissociation. See, the degree of dissociation, it is called as alpha. So relation is the degree of dissociation of weak acid or weak base and its dissociation constant. If the dissociation constant of weak acid is K, the dissociation constant of weak base is Kb, means in this Ostwald dilution law, there is a relation between alpha and K for weak acid, and for weak base, alpha and Kb. So these separate questions are asked for 2 marks. The big question, it is if it is asked, it will be for 4 marks, remember. Means explain the Ostwald dilution law for weak acid and weak base. This is a very big question. So if this question it is asked for the board exam, it will be 4 marks question. So to ask the 4 mark question, It is allowed from this year because in the section D, all the questions are for 4 marks. If you see, the question paper pattern is already given to you. The syllabus unit wise distribution is always given to you, already given to you. So we can check in this the D part of the question paper in which the 4 mark question can be asked. So in that 4 mark question, but on this topic, the 4 mark question, it is not asked because the weightage of the chapter is only 6 marks. So don't worry, this Ostwald dilution law, always it will be asked for 2 marks. So it is nothing but the relation between degree of dissociation. Degree of dissociation is alpha and its dissociation constant. So again, we will consider the equilibrium of weak acid. This is a similar equilibrium. This is already, you know, this is equilibrium constant Ka according to the law of mass action. It is given. But now, the derivation will be started. Suppose 1 mole of acid Ha. This acid, it is a weak acid Ha. Suppose 1 mole of acid Ha is initially present in volume V dm cube. So initially 1 mole of acid is present in volume V dm cube. Initially means reaction is not started. If the reaction will be started and slowly, what will happen? This will be dissociated because the reactant will be dissociated and the products will be formed. So at equilibrium, what is the position it is given? At equilibrium, what will be happen? The fraction dissociated would be alpha. So at equilibrium, what will happen? What we can say? Initially, 1 mole of acid it is present in volume V dm cube, but at equilibrium, what will happen? It will be dissociated. Fractions of Ha will be dissociated. So the fraction of acid that remains undissociated will be 1 minus alpha. Dissociated will be alpha, and undissociated will be 1 minus alpha. This can be understood by the table. So I have given this table. With this table, we can easily understand here. See, this is the reaction is given. Ha, it is dissociated, is gives H plus and A minus. So this is amount. Ha means this is amount present at equilibrium. Initially, the amount it is a present. See here at equilibrium. Initially, 1 mole of acid is present, but slowly it will be dissociated. So amount present at equilibrium, it is shown, it is 1 minus alpha. See, H plus is alpha, A minus is alpha, and the Ha is 1 minus alpha. This is amount present at equilibrium in moles. Initially 1 mole is present, but at equilibrium it is 1 minus alpha. Then see the concentration. Concentration at equilibrium, it is given in moles per dm cube. So concentration of this H plus is alpha divided by V. The concentration of A minus is alpha divided by V. But the concentration of this molar concentration of Ha at equilibrium is 1 minus alpha divided by V. This is a concentration. Now, see, according to this equation, we are going to put the values in this equation. So, the concentration of H plus is shown here. What is the concentration of H plus is? At equilibrium, you have to see the concentration. It is alpha divided by V. Alpha divided by V, this is the concentration of H plus. What is the concentration of A minus? Alpha divided by V. So these values we have to put in this equation number 3.3. So remember H plus, concentration of H plus. So concentration of H plus is equal to the concentration of A minus is equal to alpha divided by V, moles per dm cube. And what is the concentration of HA? Concentration of HA, it is given 1 minus alpha divided by V. So all these values we are going to put in this equation. We will get this equation number 3.3. See clearly this value, it is a constant H plus. This is the concentration of H plus alpha divided by V. This is a concentration of A minus alpha divided by V, and this is a concentration of HA. So concentration of HA from this table 1 minus alpha divided by V. By solving this step, we will get alpha square divided by 1 minus alpha into V. So this equation number 3.5 is only we are getting by putting these values. So if C is the initial concentration of an acid, suppose small c is the initial concentration of an acid in moles per dm cube, and V is the volume in moles per dm cube, then C is equal to 1 upon V. Now clearly see what is meant by C and what is meant by V. C is the initial concentration of the acid in moles per dm cube, and V is the volume in dm cube per mole. So C is equal to 1 divided by V. So we can put this value of C in this equation. So 1 divided by V is equal to C. So this equation 3.5 becomes alpha square C divided by 1 minus alpha. See, compare this equation number 3.6 and 3.5. This C means this is 1 divided by V. So this value of C, it is kept in this equation. C is nothing but 1 divided by V. So for the weak acid HA, alpha is very, very small. Alpha is actually very, very small because the fraction of molecules dissociated, these are very, very small. And 1 minus alpha is equal to considered as 1. So this equation number 3.6 is equal to alpha square C divided by 1. It will be alpha square C. So Ka is equal to alpha square C. Ka is equal to alpha square C, because 1 minus alpha, it is considered as 1. And alpha C is nothing but 1 divided by V. So Ka is equal to alpha square divided by V, or K is equal to alpha square C. So alpha is equal to Ka divided by C, or alpha is equal to K into V. This equation number 3.8, this is the relation between alpha and we can see this is the relation was told. This is a relation of alpha and K. This is also relation of alpha and K. So what is this equation number 3.8 indicates? This alpha is inversely proportional to its square root of its, it is given here. So the degree of dissociation alpha is equal to inversely proportional to the square root of its concentration. We can see square root of its concentration, and directly proportional to the square root of its volume. So this is equation 3.8. It is the Ostwald dilution law for weak acid. For the weak base, again we have to consider this equilibrium. We have to same equilibrium, same expression is there, but only instead of for the weak base Kb divided by C, and here alpha is equal to Kb into V. I will explain. So if we consider the weak base initially, see, this is amount present at equilibrium is 1 minus alpha. This is alpha. This is alpha, because the fraction of fraction of BOH will be dissociated. So the amount present at equilibrium will be 1 minus alpha. Here the amount of B plus is alpha, the amount of OH minus is also alpha, and see the concentration is also same as the concentration here taken of the H plus AH minus. Here the concentration of B plus and OH minus is same, alpha divided by V. So the equation is same, the all the steps are same. See, at equilibrium what will happen? This is the concentration is given, BOH concentration. This is the concentration of B plus OH minus, it is given. By putting these values in this equation, we get alpha square divided by 1 minus alpha C. Again, what is this C? C is 1 upon V. So, as the alpha is very, very small. Again, we have taken this alpha is very, very small. So 1 minus alpha is equal to 1. So K is equal to alpha square C, or K is equal to alpha square divided by V. Sorry, KB is equal to alpha square C. This expression is same like this, where K is equal to alpha square divided by V. Here we can take KB is equal to alpha square divided by V, and KB is equal to alpha square C. So alpha is equal to KB into V, or alpha is equal to KB divided by C. Same expressions are there, only instead of this K, only KB is written. So again this equation 3.11 indicates this is the degree of dissociation of weak base. It is inversely proportional to the square root of the concentration and directly proportional to the square root of volume of the solution. So today we have to make a practice of this Ostwald dilution law for the weak acid and weak base, because this is as for 2 marks. So whatever the part it is completed, the questions are asked on this Ostwald dilution law. Questions will be asked on Arrhenius theory. Questions will be asked on Laurie-Bronsted theory. Questions will be asked on Lewis acid and base theory. Questions will be not asked on this part, remember. Dissociation constant of weak acid and weak base. So no any questions will be asked on this part. Then yes, 1 mark question will be asked on it. Write write 2 example of strong acids, or write 2 examples of strong base, write 2 examples of weak acids, write 2 examples of weak bases. So for the 1 mark, the questions will be asked on it, but they will not ask how they will be dissociated. For the section A, there is a chance to ask the questions on it. Write 2 examples. Also, for 1 mark or 2 mark, this question it is asked, explain the amphoteric nature of water. So we have to write these 2 equations. This is the equation with ammonia, and this is equation with HCl. We have to write these 2 equations. And again on this conjugate acid base pair, 2 marks question can be asked. Explain the conjugate acid base pair. So whatever the part it is explained, degree of dissociation, this will be not asked for the examination, but the definition can be asked for the examination. What is mean by degree of dissociation? Remember. So today, this is today's homework for you. Make a practice of this Ostwald dilution law for weak acid and weak base. So I'm going to stop here. Also, we can solve these examples. These examples are based upon the Ostwald dilution law. At your home, just see these examples. Already I have given the PDF to you. Just go through these examples. This example, it is 3.1 can be asked for 2 marks. Then 3.2, it will be asked for 2 marks. Then another 2 problems are given here. 3.